Welcome to Baozi Training Leetcode solution. If you want the best marketing experience in North America, feel free to check us out at baozitraining.org. Also, feel free to subscribe to our, first of all, YouTube channel, and also subscribe to our WeChat, where we constantly publishing some technical blogs. So today we're going to talk about this problem called word pattern. It's marked as an easy problem. So as some of you know, some of you may already know, the easier the problem is, the more ways we can solve it, right? So let's talk about this problem. The problem is giving you a pattern, a string, find if string follows the same pattern. So what does it mean? For example, the pattern, basically they just use characters, single characters as a pattern, like A, B, B, A, and then give you a string, could be different words. So dog, cat, cat, dog. So this is basically follow the pattern of A, B, B, A, so return true. However, they have like an interesting case, which is ABBA. So this is not ABBA because they're all the same. So it should be AAA. So this should return false. So I think they also mentioned this word called bijection. So that pretty much explains to you this would be a one-to-one mapping. So the thought process of this problem is, first when I got this, right, it's kind of very similar to the isomorphic string problem where I will explain it later. But essentially my first thought is trying to encode the strings. So first I will encode the string and spit out into something, and then I will use the same encoding algorithm to encode this ABBA and also spit out something. So, and then I will compare these two things. So that said, so what I end up doing is, for example, if you have a string, is basically what I just want to do is basically start with letter A and then put like an integer as index. So if I see this character before, I will just get it from the hash map, or else I will just basically use that A plus a integer so that I will get the encoding of the string. So essentially, for example, this one, I will encode it as first I see this A, so then there's another letter, so this will be ABB. If your pattern is BCC, they will also be encoded as ABB because it doesn't really matter. As long as the first time I see it, there will be A plus 0, and then later, the second time I see it, see another character will be A plus 1. So that's one way. And then another way, basically, as it's mentioned, is basically bijection mapping. So a quick Wikipedia here. Injection is basically you have all the value, it map one-to-one to other things, but you don't need to map all the values. So bijection is basically all the values need to be matched once and exactly once. You cannot have, like, for example, two values mapped to the same thing. And then, yeah, this is basically this is not a bijection. So this is basically a what do you call it, surjection, is as long as all the values are mapped. So basically this is a surjection, this is a surjection. All the values in Y are mapped, then it's a surjection. Doesn't really matter to this problem, but as you can see, the idea is also very simple. So what we do is we basically go through we build a one-to-one mapping between the pattern and also the strings. So it's like, okay, if you see this character, it's mapped to this string, right? And then if you see this character again, it has to be that exactly the same string. However, that's why we have this edge case that we really need to take care of, because you cannot have two strings that map to the same value. For example, A mapped to dog, and now you have B mapped to also mapped to dog. So you probably need either a separate, like a hash set, just to check the duplication of that part. Or else this will return true, because if you don't have that check, A maps to B, looks good, and then B is the first time you see B maps also to dog. So basically your hash map will have two values, which is, you didn't check the duplicate part. All right, so the code is here. It's relatively straightforward. This is basically, I wouldn't recommend this solution because this is literally what I did in the first pass. So like I said, first I'll check the string length. If they don't share the same length, of course they are not in the same pattern, right? And then I will encode the pattern, I will encode the string array, and then I will compare them. So the way I encode, basically the same thing. So basically for each of the string, if I see it, so I will just basically, directly look into the hash map and then get the value. But if I don't see it, so it's the first time, so I would start with A. This index basically is outside of the for loop. That would be starting from 0. So and then just keep appending. So same thing for encode the string. It's basically essentially the same algorithm, and then so that later I will compare the compare if they're the same or not. So in this way, so think about it, I don't actually need to dedupe anything, right? Because they will basically be translated into same thing, like dog will be translated into a. So the time complexity of this is apparently O(n), even though we loop the three times, because we have to encode string, encode array, so it's still O(n). The space complexity is O(n) because we use extra map. This bijection mapping is what I recommended. So first thing, doing this length check, and then I'll keep a hash map. So maintain this mapping. So as long as it contains the king but the value is not the same, then basically that's a false. Or else this is like basically you put the mapping. However, you need to have this mapped like set to dedupe. So this is just prevent the two values mapped to the same thing. Oops, I put this shit. Just know put actually returns a v, which is the previous value or not if it doesn't exist or answer the value. Okay, I think I wrote this code like 4 years ago or something. So apparently, if you want to optimize your code, just remember I thought I remember it wrong. I thought map put it returns a void, but apparently it returns the previous value if it exists, or no, if it doesn't exist. So in certain ways you can use this to save one operation, which is map.contains, but it's O(1) constant. Doesn't really matter that much in my opinion. In Leetcode discussion, there's a clever implementation. I wouldn't recommend this in the real code interview, but it's just kind of the guy's very similar idea, but instead of he basically saves a set. So what he compares, instead of the key value part, is more like the key is the word or the character, and then the value is actually the index. So as long as the index are not the same, that just means it's either not the same or you actually seen this character before, so you basically return false. Yes, same time complexity. So the caveat is I wouldn't recommend this. I just put it here FYI, and then this would be what I recommended. And just remember, the put actually returns a value that I forgot. All right. If you have any questions, feel free to leave any comments down below. So until next time, I will see you then.